Polynomials. Dear students, in this series of polynomials, till now we have seen about the types of polynomials depending on their degrees, like degree 1, so linear, degree 2, so quadratic, degree 3, so cubic, and degree 0, so constant. Then we have seen that what are the zeros of the polynomial. If degree is 1, so there will be 1 zero of the polynomial. If degree is 2, like quadratic, it will have at most 2 zeros. If degree is 3, that is cubic, so it will have at most 3 zeros. And in the last part we have seen the graphical representation of the polynomials and their representation of zeros, and along with that we have seen a relation between the zeros, if you remember. Yes, so what we have seen, that if ax square plus bx plus c, if ax square plus bx plus c is a quadratic polynomial, and if alpha and beta are the zeros, then a, b, c are the coefficients of the given quadratic polynomial, and the relation between the zeros and the coefficient is given by alpha plus beta, that is the sum of the zeros, is minus b by a, that is minus of coefficient of x upon coefficient of x square. Product of the zeros, alpha into beta, is equals to c by a, that is constant term upon coefficient of x square. So this we have seen now till now. In today's part we are going to discuss one very important type of question, which is surely it is that type is there, that it will come for the board exam, and it depends on this relation of the coefficients and the zeros. Before that, we need to understand, before we start with that question, we need to understand the relation between a quadratic polynomial and this relationship of the zeros. Okay, in case alpha and beta are the zeros and alpha plus beta is the sum of zeros, and alpha into beta is the product of zeros, then how we can represent a quadratic polynomial, how I can show a quadratic polynomial. So if alpha plus beta is the sum of zeros and alpha into beta is the product of zeros, then the general representation of the quadratic polynomial is given by x square, because quadratic, minus, listen very carefully, x square minus sum of zeros into x plus product of zeros. So I can say that in general the polynomial is written like x square minus alpha plus beta into x plus alpha into beta. So this is very important relationship that we need to know. What is important here? This minus sign. Okay, so that minus sign is there before the middle term. Okay, and before the final term, that last term, it is a plus sign. Okay, so let's see a question of this type. So here is the question: if alpha and beta are zeros of the polynomial 3x square minus 4x plus 7. Okay, polynomial is 3x square minus 4x plus 7 and alpha and beta are the zeros, then we have to form a quadratic polynomial whose zeros are 1 upon alpha and 1 upon beta. This is a question which surely, very surely comes in the exam, and at first glance it looks like very difficult, but I will prove you, and you will see here in this video only, that this type is very easy, but because we do not understand it properly, and that's why we do not attempt such a question. Okay, so let's have the solution. So first we need to represent this polynomial as p of x. Let p of x equals to 3x square minus 4x plus 7. Now what they are saying that alpha and beta are its zeros. So we know the relation between the sum of the zeros. We can say alpha plus beta. What is alpha plus beta? Sum of zeros is equals to minus b upon a. Now in our case we need to know what is a. In our case a is, you can check here, a is the coefficient of x square, that is 3. B is the coefficient of x, that is minus 4, and c is the constant term, that is 7. Is it very clear? So what is minus b by a? So we can say minus b by a means minus of minus 4 upon 3, that is 4 upon 3. This is the alpha plus beta. Okay, 4 upon 3. And alpha into beta, what is the relation? Alpha into beta, that is product of zeros, is c upon a. What is c in our case? It is 7 and a is 3. Okay, so alpha plus beta's value is 4 by 3 and alpha into beta's value is 7 by 3. Now you will think that how we are going to use these values for the another quadratic polynomial. Now we know very well that for the new polynomial the zeros are 1 upon alpha and 1 upon beta. Okay, and we know one more thing, that the general representation of polynomial is x square minus alpha plus beta into x plus alpha into beta. Okay, so if we can get the sum of the zeros for the new polynomial and product of the zeros for the new polynomial, then definitely we'll be able to find the given quadratic polynomial. For the new quadratic polynomial, the zeros are 1 upon alpha and 1 upon beta. So first we need to find sum of zeros for new polynomial. Sum of zeros for new polynomial, so it will be 1 upon alpha plus 1 upon beta. Why? Because 1 upon alpha and 1 upon beta are the zeros. Now we will not stop here, we will do the cross multiplication. If we do cross multiplication, what we will get here? This beta will multiply with 1, alpha will multiply with this one, and in the denominator they will multiply with each other. So we will get here beta plus alpha upon alpha into beta. This is cross multiplication. Okay, now if you can see here, alpha plus beta, this numerator, its value is here. What is its value? 4 by 3. So we can write sum of zeros as 4 by 3. And what is alpha into beta's value? It is 7 by 3. Okay, so this 3 will get cancelled. We will be left with 4 by 7. So what is the sum of zeros? 4 by 7. Now same way we need to find the product of zeros for the new polynomial. Now what is the product of zeros? 1 upon alpha into 1 upon beta. Okay, so what we get? 1 upon alpha into beta. Correct? So what is alpha into beta's value? Alpha into beta's value is 7 by 3. Okay, so what we get here? 1 upon 7 upon 3. Okay, so on reciprocal it will give us 3 upon 7. Is it very clear? Is it very clear? Okay, so in this case our product of zeros is coming out to be 3 by 7. Now what is the polynomial? Then we know that required polynomial, we will write it as required polynomial is given by x square minus sum of zeros into x plus product of zeros. Okay, so x square minus what is the sum of zeros? We are getting 4 by 7 x and plus what is the product of zeros coming? 3 by 7. Is it very clear? So our new polynomial will be x square minus 4 by 7x plus 3 by 7. Okay, so this is our required polynomial. Okay, in general if we want to multiply by 7 throughout, so it can be represented as 7x square. If you want to take LCM, that will be 7x square. We can write it as 7x square minus 4x plus 3 and whole multiplied by 1 by 7. This is the another representation for such type of polynomials. So here we have discussed a very important type, okay, which is just you can see here what I did. We have just represented the relation in the form of new zeros, alpha plus beta and alpha into beta. Okay, and just we have substituted those values here in this equation. Okay, and we'll get the required polynomial. This is very important type which comes for 3 marks very surely. Okay, 3 to 4 marks it comes very surely. Yes, so hope the type is clear, and in case there is any doubt, see why we can understand the things in a better way with the help of a video, because we can go back, we can reverse the video, we can move forward. That is the simplicity related to the videos of and mathematics is a subject where we need to go back, we need to understand it again and again. Okay, so yes, you can utilize these videos very nicely if you wish to. Okay, so with this we'll stop here. In next part we are going to discuss one very important type of question. Okay, so we'll meet in the next part. With this we'll stop here. Take care.